Well, it's no secret that AMD has the fastest processors right now, gaming or otherwise. But it changes the equation a little bit when you can get the Core Ultra 2 65K for like $230 at Micro Center. That's what I did. So it's on sale. It's been on sale on Amazon too. We're going to do a build. We're going to do a build around the B860i Edge TI Wi-Fi. This is mostly a video about this ITX motherboard, but this ITX motherboard paired with the Core Ultra 7 because compute per dollar, pretty good value. And this is also a B860 board, so B860 again, compute per dollar. But this has a lot of cool features like 5 gigabit LAN. All right, let's talk and let's get building. Okay, I've actually got 3 builds I'm gonna do. This is just the first one. I already did one. I was impatient. But I've still got 2 processors in box here with all my stickers from Micro Center. These machines are gonna be around the office machines, and that's really their role in life. So they're not gonna be, I mean, there might be some light gaming sessions. It's like, oh, it's the end of the day. Let's play some games. But they're not gonna be the highest end. I mean, the Core Ultra 7 will run a 5090 just fine. That's not a problem. But it's not meant to be the highest end. It's meant to be the thing that if you were spending money, what's the best value you can get per dollar? And believe it or not right now, if you can get, I mean, this thing, the Core Ultra 7 with its P&E cores for $230 is a steal. $230, $250, somewhere through there. I realize that depending on where you are, you might not be able to get that. And the pricing equation changes a little bit, but basically, by and large. The MSI MPG B860i Edge TI Wi-Fi, that's the motherboard we're going to use for this. Now, ITX is an odd something valve. Now, I will grant you, ITX is an odd choice if you're going for value per dollar. It doesn't make sense to go with ITX for value per dollar, but sometimes you also want a compact system that will sit behind the monitor because you don't want to put it on the floor. So I've got a couple constraints with this first build where they're like, okay, it's just going to be mostly for business, but it's going to sit on a desk and it should be a small case and be out of the way and also not be excessively loud. It's like, okay. Micro ATX would not be a bad choice, but in this case, I'm going to go for ITX. This board, well, before we get to the board, let's also talk about cooling because that's the other consideration. When you're doing Intel, especially a K processor, it is overclockable, but even when it's not overclockable, there's this like PL1, PL2 thing that Intel does. And so if you get an OEM system that's based around like the 285 or the 265 no K, those processors will consume less power. But some OEM motherboards or some system integrator motherboards will let you give them more power all the time. Like as if they're a K processor, you're not changing the clocks, you're just letting the CPU use as much power as it wants to, and you will get significantly better performance with that. We did a review on an MSI DP400 pre-built, and it was exactly like that. The motherboard came at the Intel bone stock defaults. If you turn that on, you get more free performance, and 99 out of 100 times, or maybe even 999 out of 1,000 times, that doesn't introduce stability issues. 13th and 14th generation Intel notwithstanding, because that's a whole other story. Core Ultra, not very many reports, if any, on the level 1 forums, so that's nice to see. Inexpensive tower cooling, the FSP MP7 is not a bad choice. It's not the only choice, but it's also not a bad choice. For the memory, I managed to find some 48 gig DIMMs, so this is going to be 96 gigabytes of memory, even on an ITX platform. This is the G-Skill Flare X. It has pretty reasonable timings at 40, 40, 40, 89. It is only 5600. 5600 is a JEDEC standard. The Intel platform here can do much, much better in terms of memory speed, but no one wanted this, so it was cheap. It's good. It's fine. It's good for the price. All right, let's take a closer look at our ITX motherboard. So what you get in the box is a fancy, quick disconnect Wi-Fi antenna. That's good. It's built-in Intel Wi-Fi 7. Also, the built-in Intel Killer 5 gigabit NIC as well. That's the B5000, I believe. That's it. That's the motherboard. It's so cute. Also in the box, you get a front panel extension, a Corsair RGB header breakout, some M.2 mounting screw accessories, the manual, a single SATA 6 gigabit per second cable, because no one is using SATA anymore. And that's pretty much it for box accessories. Now, the rear I/O layout is pretty interesting. It's HDMI out, you have a clear CMOS button as well as a BIOS flashback button. The flashback button is slightly more recessed than the clear CMOS button. Then you have a 40 gigabit Thunderbolt port, 4 Type A, 5 gigabit USB ports, 2 10 gigabit USB ports, 1 Type C and 1 Type A, your 5 gigabit Intel LAN. Now, even though the antenna is quick disconnect, you do have RPSMA threads. So if you prefer a different wireless antenna, you can use the threads here and get there, I think. Then you have analog out, analog in for microphone, and optical SPDIF out. And that's pretty much it for the rear I/O. In terms of the board connections, you have a USB 2.0 header as well as a 5 gigabit front panel connector as well as a Type C front panel connector. There's 2 6 gigabit per second SATA ports, 1 8-pin power input, your standard ATX 8-pin power input. At the top edge of the motherboard, we got another 2 RGB headers, 1 for your 5050 and 1 for your addressable RGB. There are 2 4-pin fan headers on the top and 1 on the front for a total of 3. Your primary Gen 5 M.2 on the top here is under this edge heatsink. And then on the back of the motherboard, you have your second M.2 slot. Your front panel audio header is located right here. And there's plenty of clearance for the GPU, which is nice to see. You can't really see it too well, but the Wi-Fi solution is modular. It's got like an E3 style riser. I'm not sure if that's proprietary or not, but it is at least modular. I suspect that it's not proprietary at all, but I'm not going to take it apart because I need to test it. Maybe after we're done testing it. Now, one thing that I'm curious about with this board is what's the maximum memory speed that it supports? So I do have our Trident Z 8000 memory. So we will also be trying that in this configuration. Now the MP7 or the black MP7, MP7B, you know, this is the non-black version. It comes with a special screwdriver. This is the only thing that I can really complain about because you need a special screwdriver to install and remove it. But otherwise, it's a pretty good deal. It comes with its own mounting backplate. Has color-coded installation kits, so you know if you're getting into Intel or not Intel or whatever. And installing this before you mount it in the system, CPU, cooler, RAM, definitely pro strat. I think in most cases, it's also easier to go ahead and install your M.2 while it's out of the system as well. Unless your case has a cutout on the back for getting to the M.2. The FSP comes with reasonable thermal paste, but since I'm doing a repaste job here, we're just building stuff out of stuff I've got laying around. It is Arctic MX6. That stuff's good. Whenever I'm mounting a heatsink or putting a heatsink on, I always like to go corner to corner when I'm installing the retention bracket. That just helps make sure that the number of screw turns, like the pressure, is even, because if you tighten down one side, it may become physically impossible to get the other side down the way that it should be. So you just kind of snug corner to corner. Same thing when you come to actually mount the heatsink. You're gonna take the special screwdriver and feed it through the heatsink. You kind of just want to start like 2 complete turns and then switch to the other side and make sure that it's started. Maybe do like 4 or 6 complete turns and then come back to the other side and do about 2 turns at a time, sort of rocking it back and forth so that you're tightening the heatsink down evenly. Now that's not necessarily strictly required and they don't always instruct you to do it that way, but usually it is the best idea to at least get the threading started on one side, because if you completely loosen this on one side, the way that it's spring loaded, it'll pop loose and you may never have a good thermal connection on your CPU. I was chasing some of the CPU exploding controversy, thinking that maybe that was part of what was fueling the CPU not being able to cool itself and having failure, because if you don't adequately cool these CPUs, it can run into problems, and that's true of any modern CPU from any brand. They've got lots of leftover hardware for this. It is worth your time to put it back in the box and save it. 1, because you never know when you're going to switch teams. And 2, you're going to need that screwdriver when you take this apart. The mechanism for the heatsink is just little clips. Now, another thing that's nice about our cooler here is that it has adequate clearance for the RAM. You don't always get that. Sometimes you might have to adjust the fan up and down a little bit in order to clear your RAM. But on this motherboard with this layout, with the DIMMs that I'm using, I've got clearance. Obligatory airplane reference. Clearance. What's the clearance? Clarence? Roger, Roger. Now, normally we would go ahead and install this in a case. I'm going to set this up on a test bench because we've got more to do than just immediately jump to our relatively pedestrian 5600 memory. We've got to test it at 8000. We've got to do benchmarking. So let me grab a test bench. Now, for the power supply, for a build like this, it really doesn't matter. It's hard to recommend a power supply less than 750 watts these days, just because you never know what you're going to upgrade to. I mean, if you put a modest GPU in this, like a 300 watt GPU, this setup, is going to be 250 watts at peak at most. You could get away with a 650 watt power supply. I would strongly encourage you to think about an 850 watt power supply or greater, because you never know what you're going to want to upgrade to in the future. And if you've got an 850 or 1,000 watt power supply, chances are you're going to be able to use whatever the next generation hardware is. Or you could put in a fancy 600 watt GPU, 600 watt plus 250, 750, 800, get a little bit of margin there. 850 watts makes sense to me. The lowest I would go is 750 if you're sure that you're never going to upgrade to anything really high end. Even if you're just going to put a modest GPU in here, 750 watts is the starting point that I would recommend. FSP also has some pretty good power supplies. This is a Tai Chi power supply that's in our test bench, but this is overkill because it's 1600 watts. It's designed for like dual RTX Pro 6000 GPUs. But that's what this bench is for. So, yeah. We've also reviewed Seasonic and Corsair. Generally, those are good power supply brands. But right now on Newegg, FSP power supplies are a pretty good deal. And some of the ASRock power supplies are also a pretty good deal, depending on what you're looking for. Not sure what's actually going to end up in the build. For now, I just want to do the testing. Hello. Let's start with the 8000. All right, 3 kits of memory we're going to test. First is the ADATA 8600 CU DIMMs. CU DIMMs are kind of hard to get right now and probably not worth it unless you're building an ultra high-end build. But this kit of memory from ADATA is a really nice kit of memory, and this is the fastest memory that I have. And this is Intel platform only. CU DIMM is an Intel thing only. So we're going to see if this little thing can run at 8600. Just, it gives us an idea of the board quality for the MSI B860i. A nice feature on most MSI boards is it gives you a diagnostic LEDs on the front, so if something doesn't boot, it at least gives you an idea of where things are maybe going wrong. Sometimes your GPU may not be seated. I don't have a GPU in this. I'm using HDMI out. Sometimes your memory might not be seated correctly. Sometimes it might be a CPU problem. So red, yellow, and then you get green or white depending on if it boots successfully. The first time DDR5 booting a system like this, it's going to take a little bit, potentially. It could take up to 10 minutes. It just depends. And you can hear our CPU fans ramping. That is about as loud as the CPU cooler gets. It's moving quite a bit of air, and we're just waiting for post. Hey, we posted. I made one terrible mistake, though. I didn't notice. We got KFs, because those were the ones that were on sale. So KF means there's no iGPU. The iGPU is disabled. So I got the white LED here, but there's no post. It's not working. So a trick you can do, this is a Keychron K10H. I've been using this for a couple of weeks just to test it. It's no substitute for my Model M, but it is a very nice keyboard. And it has lights, unlike my Model M, because I got the compact Model M. And so if I turn caps lock on and off, or num lock on and off, it works, it responds. And that means the computer is actually working. It's something with the display. It's like a pro diagnostic tip there. If it responds to num lock and caps lock, 9 times out of 10, it's the computer. Although I have run across a couple specialty gamer keyboards that'll turn numlock on and off on the keyboard. Like, it'll work even when there's no USB connection. That is evil. That is bad design of the keyboard. Shouldn't do that. Anyway, I need to add a GPU to this. Here we go. Our Sapphire Radeon 9060 XT, which would be, for the stated use case of this build, occasional gaming. This, at 9060 XT with something like this, it's going to be a nice build. Oops. There we go. That's what we should see at first boot. We've booted into BIOS. Here you can check to see what BIOS version you're on. You're probably going to need a BIOS update. You should do that before you do anything. You can also see the memory is on a standard profile. We're going to go pick XMP and see if it works with that crazy 8600 and test a couple of our memory kits before we get started installing our operating system and everything else. Here's a quick BIOS tour of our B860i Edge TI Wi-Fi. It starts on the easy mode screen, but also pay attention, there's advanced F7 in the corner. From this screen, MSI performance preset, and this is true on pretty much all MSI motherboards. You can click that and you can pick just the first option, and even if you have a non-K processor, this will let the processor use more power, and the processor itself controls how much it's using the power to do computation. And so at the Intel default settings, it's power limited. The processor has the ability to boost for very short periods of time, but it's designed for this cooling solution. It's designed with this cooling solution in mind. This is obviously much better. And so this will keep the processor cool. And if the processor stays cool, generally it stays stable. And so you can give it more power when you've got a better thermal situation. And that's true whether it's a K or not a K processor, which is sort of fun. Even though this is a K processor, we're not going to overclock it because we don't really like the core. The reality is that the Core Ultra CPUs, you really don't have a ton of overclocking headroom. And the overclocking headroom that you do get from the K is more like oriented at people that are interested in extreme tweaking and that may be chasing down some better memory performance or better performance in the fabric and not just the raw clock speed of the cores. Intel's pretty much squeezed out as much clock and boost performance from these CPUs as you can get. The power thing is definitely good because it's like the whole power performance curve. That's a different conversation. But with the unlimited power, letting the CPU do what it wants, 99, maybe 999 out of 1,000 times, it is perfectly stable and reasonable. XMP, especially when you're pushing XMP into the higher ranges, can introduce more instability than the higher power limit, which is wild to think about. But 8600 is really pushing it, so I'm going to give it as much power and memory clocks as possible. Now, to test stability, generally, I like to use two things. MemTest 86, that's from Passmark, that's really good, and also YCruncher. YCruncher does computation plus memory stuff, and that can show you instability in your system that doesn't exist with just MemTest 86 alone, because MemTest 86 is really testing the memory, but the entire rest of the system isn't doing anything, whereas YCruncher is doing insane math and memory stuff at the same time, and so that can expose instability that MemTest 86 does not. In our MSI performance preset, there's 4 options. The extreme, we're going to stay away from extreme, and those are for extreme overclocking and everything else. There's also memory try it, which we'll talk about in the advanced section. That's a lot of fun because if the 8600 doesn't work, you can choose a lower speed. You can choose a lower speed, and MSI will do some things to try to get you some of the performance back that you otherwise would miss out on just a pure clock speed conversation. There's also MSI driver installer utility. Operating systems have this feature now where it'll auto-install. Like when you install Windows, the BIOS tells Windows, hey, go run this executable, and it's just an arbitrary program. And a lot of people don't like that for security reasons. I always disable that. And then, of course, setting our XMP1 profile. Now, as we know, the BIOS on this is out of date, and we're going to need a newer BIOS. It makes sense to do that before we do any of this. Updating the BIOS is really easy. Just go to MSI's webpage, put in, it's like B860i Edge TI Wi-Fi. Cool. Downloads, BIOS, look for the latest BIOS. You can read the release notes and see what they fixed. And then you just copy it to a USB key. You got to unzip it. It comes as a zip. You expand the zip. And it's going to be a file name like 7A, whatever. Just looks like random gibberish, but that's okay. Plug it in the back here. Now, sometimes there's a special port labeled on the back. And that is the port where if you hit the button, the board can self-flash, but that's more steps. This is the GUI step. Like when the board self-flashes, you have to rename the file on the USB stick, and there's a couple other steps. You got to do more reading. It's not what we're doing. It doesn't really matter which USB port you plug it into. Most of the time, sometimes it does, but most of the time it doesn't. So if it doesn't detect your USB, try a different USB port. Go into BIOS, and then we'll flash from BIOS. But if it doesn't work, you can always do the longer procedure where you hit the button on the back, and then it'll self-flash from USB. But you got to make sure the USB is formatted right. Generally, the BIOS is got to be the only thing on it. Blah, blah, blah. Whereas with this, I'm using an Ubuntu installer, and the BIOS is on it, and that'll work fine. That generally doesn't work fine with the push the button on the back, but it does work fine with the BIOS. In the BIOS, I chose the mFlash utility, and I hit yes, and it wants to reboot, and then it takes me to this, and then it gives me a little preview of my USB flash drive, and then I can browse and find the file on there. And then it takes it a second to analyze, make sure that I got the right file. If you get an error, chances are you downloaded the wrong thing. It might be the Edge TI, not Wi-Fi, or the B860iX, or some other different model. You got to really make sure the model's exactly correct. Sometimes if it's very old, you also have to update to something in the middle and then something a little newer, which is why it's worth checking your BIOS version. You guys are like, oh, it's 1.0 and we're on 7.0. It's like, well, you might have to go to 4 or 5 and then to 7 in order to get it to update if you get an error message about it not recognizing. But then it's going to do the BIOS update thing. And that's pretty much all there is to update the BIOS. That is really easy. It is good practice. It is good computer hygiene to update your BIOS periodically as well. Although sometimes they'll tell you, if you're not having problems, don't update your BIOS. I don't know that I subscribe to that theory, because I could be having problems that I don't realize I'm having. Our ADATA kit, which has been an amazing kit in other motherboards and other configurations on the Intel platform, mostly tested with the Core Ultra 9, doesn't work here. 8600 is right out. 8000, our second XMP profile, can work, probably with a little bit more tuning. It's almost stable, but not quite. Memory Try It here was useful, stepping down to like 7200. 7200 was okay. Let's try our G-Skill 8000 kit. Yeah, would you look at that? This is not a CU DIMM. The CU DIMMs were just sort of launch era things. So I think the lesson here is maybe don't use CU DIMMs. DDR5 8000 is perfectly stable on the G-Skill kit, which is not a CU DIMM kit of memory. Fun times. It's only a total of 48 gig. It's two 24 gig DIMMs, which may also help. The ADATA memory were also 24 gig DIMMs, 24 gig DIMM to 24 gig DIMM, but my 5600 kit is 48 gig DIMMs for a total of 96. So system memory total 48 gigs, bumping that up to 96 gigs, because again, it's going to be used for work stuff mostly, and a lot of things running at once. One thing MSI has added to their BIOS is root port ASPM control. This is PCIe power management. Some NVMe, like Samsung's been pretty guilty of this, don't handle power management correctly on PCIe bus. It can lead to blue screens and corruption. Sometimes disabling power management for those NVMe devices helps. And so it's nice to be able to do that on a port-by-port basis on this motherboard. This motherboard also supports RAID. You could run Intel VMD RAID, like a RAID 1 or a RAID 0, but because your M.2 are mismatched, one's Gen 4, one's Gen 5, don't know that I would recommend that, but if you had two Gen 4 SSDs, you could do that. It also supports hot plug on the SATA ports. So in the past, we've reviewed IC dock accessories and other hot swap accessories where you can have a hot swap 3.5-inch bay wired into your computer or available in your case. And so you can turn this on, and then you can hot add and remove hard drives, which is pretty awesome if you just use those as like data storage. This BIOS also exposes a lot of Thunderbolt and Thunderbolt compatibility options, so if you have a Thunderbolt 2 peripheral that you're looking to add support for, chances are the settings that you'll need for compatibility with legacy Thunderbolt devices is exposed here in the BIOS, which is welcome news. There's whole threads about that on the Level 1 Text forum. So if you do pick up one of these motherboards and you have Thunderbolt compatibility issues, hit us up in the forum, because I'd love to document that. Even being an ITX motherboard, this motherboard is somewhat power limited. You're not going to want to dump 400 watts into that Core Ultra 7 chasing those overclock rainbow unicorns. You do have overclocking features in the BIOS. The most useful one is Memory Try It, which is not really even overclocking. Memory Try It, notice there's a CL number out there from the memory frequency. And so if you have memory that won't run at 8000, but maybe would run at 7200, you can lower the cache latency so that it better corresponds to the clock rate that you've chosen for the memory. What I mean by that is that memory that's DDR5 8000 CL40 may be stable at DDR5 7200 CL40, but CL40 is an even higher latency than CL40 on 8000. You may be able to lower the cache latency from 40 to 36 or 34, maybe even 32, but there's a lot more latency numbers than just the one. And so this is a set of presets that MSI has loaded in their BIOS. When you pick the lower CL number, it's actually changing a lot more than just that under the hood. And so this is useful for when you have some memory compatibility issues. And generally, we found that MSI lately, in the last generation, not just Intel, but also AMD, has been doing a really amazing job implementing support that works properly for these higher rate DIMMs. And a motherboard that physically has two DIMM slots generally has an easier time doing the higher memory clock speed. So it's nice to see that in all of the overclocking stuff. You can also turn on and off P cores and E cores. You can also control the clock rate. Sometimes it's about power management. You just want to lower the amount of power being used. All the options are here for that. And boom, there you go. That's pretty much it for this build. Now I need to put this in a case and do all of that, but I'm probably going to use, again, small form factor, compact, ITX, maybe a micro ATX case. I have not quite figured out those details just yet, but this is pretty much what you need to know. Now for storage, you're going to want to pick a good M.2. Gen 4 versus Gen 5. If you're looking to save some money, you can get some killer deals on Gen 4 SSDs that you'd be hard pressed to tell a difference in real world usage between Gen 4 and Gen 5. Sometimes it can make a little bit of a difference loading levels in games, But we've taken a look at the Crucial T700 line. I think those have been, I think Crucial has some updated drives I haven't got my hands on yet that are even faster. Yes, those are amazing, very fast drives. We've also taken a look at Samsung, like the 980 and the 990, but man, Samsung has really fallen off. I haven't gotten some of the new model Samsung because I was really disappointed with the Samsung 990. Those are not holding up well in terms of longevity and firmware updates and everything else. I still have a lot of Samsung 980s in service, and I probably, if there's old stock of like a 980 somewhere and it's on a pretty good deal, I'd probably still buy a 980, but I think I would shy away from a 990 at this point. It's like a 1 or a 2 terabyte capacity. You might consider a 4 terabyte M.2. I mean, it's a little bit of a splurge, but with the amount of space, literally everything from games to AI to applications are demanding these days, it's kind of nice having all that in one drive. But if you get started on a build like this, or you have questions, or you just want to show off pictures, hit us up in the forum. This has been a quick look at the MSI B860i Edge TI Wi-Fi and the features that it offers. This board also works pretty well with Linux. You can boot it up and do, you know, your Linux stuff. That also works fine. If you want to, if you're really like doing a super budget build, I don't know, hit us up in the forum. Check out some of the other more affordable boards. MSI also has some pretty good options in like the Tomahawk line, and like, you know, they've got the MAG. You might also check out the MPG line. You got some options. I'm pretty impressed with the FSP coolers, and yeah, I'm really impressed being able to get a Core Ultra 7 for like $230. That's a great deal. It's a fantastic deal for the amount of compute horsepower. Anyway, I'm Wendell, this level 1. This has been just a quick build, just some fun. You know, that's what we do around here. If you have any questions, hit me up in the forum. Signing out, and I'll see you there.